Oh boy, this is why you got to be careful with your oscilloscope leads, apparently. I've never had this happen before, but the ground from my oscilloscope lead shorted out this ultrasonic cleaner. This is the CD2800, and when I touched I had ground and pin 1 and pin 3, which is ground and output respectively. Wanted to see what frequency this 555 timer was operating at. And so I put my leads on those while it was powered. It blew up the 555, it blew up the NPN switch for the relay, and then it burned up 2 ground traces for the NPN and for the 555, and then immediately, basically totally burned the trace coming from the transformer, which was the 12 volts, or actually 20 or 12 volts AC. Yeah, by the way, this uses 12 volts for the whole thing because it needs it for the relay, so the 555 is operating at a pretty high voltage, actually. There's no regulator in here, which is probably part of the problem. There could be a 12-volt regulator of some sort. But yeah, I'm not sure why that would make everything just blow up. But that's what it did. It's working now. I got it to turn on and start humming and everything, so pretty happy with it. But I'm going to reinforce some of the solder points on the high current, high voltage stuff, and put this back together. I guess I can't measure the PWM for now, but I'm probably like 40 kilohertz or something. This is an old CD2800 ultrasonic cleaner. They actually are still in production, although this one's clearly old. It's all yellowed and stuff. And boy, is it in bad shape. But I opened it up to learn about it, and I broke it. But I also repaired it, so you know. These are the 2 parts that broke, by the way, including like 3 traces. It was pretty bad. It turns out the ground is not isolated on this at all, so when I touched my oscilloscope ground probe, it shorted it out. What's really more surprising is that my oscilloscope is not isolated. That's really bizarre. And I learned a thing today. But yeah, a quick rundown of what's going on here. These are pretty interesting. You have a transformer in here, of course, and you have a bridge rectifier. Probably over here is the bridge rectifier, and that's going to generate 12 volts for your, it's like 12 to 13 volts for your NE555 timer. That, and then it also, so that generates the voltage for that. And then you also have your AC circuit, which goes through, I believe, this inductor and works in conjunction with these 2 switching. I haven't actually looked these up, but probably switching transistors of some sort. And then you have your relay. So how this all works basically is this guy gives 12 volts, 13 volts to your 555. That generates probably a monostable one-shot pulse. Not one shot, sorry, it's a pulse that it generates. And then it's going to have an RC circuit that will make that pulse continue to generate for 3 minutes, because this has an auto shut-off of 3 minutes. That it's doing all this without a microcontroller is pretty amazing and kind of ridiculous. Like, you could have a $1 microcontroller in here and this circuit would be a whole lot simpler. But anyway, they're generating that pulse, and then this single transistor here takes that pulse and generates it with the relay. And so the relay oscillates, and then that relay is running the voltage from these switching chips to the transducer. The transducer is the thing that probably costs the most, and the thing I know the least about. It's a heating element that vibrates, apparently. Yeah, I don't know a ton about these, which is why I wanted to open it up and learn about it. Pretty interesting stuff, and I'd like to modify and make my own. I was going to try to inject my own signal into this one because it's not isolated. It's kind of dangerous. What ended up happening, I ended up blowing the 555 and the output NPN. The NPN, by the way, is just a regular NPN that needs to drive around 100 milliamps or whatever the relay requires, because that's all it's doing is driving the relay. But yeah, also, like, there's no like liquid protection for this thing, so if any liquid gets in through the crevice here, like it's not even like a rubber seal or anything. And it's on the bottom. It's underneath a tray that holds liquid. It's dangerous, folks. But, yeah. Anyway, interesting stuff. I want to learn more about ultrasonic cleaners.
and I want to design my own upgrades for them because I think they're too expensive for what they're actually doing. So stay tuned for more.